In this video, we're going to be talking about making the telescoping screw, which is going to be the second part that we're going to produce after we get done with our two base pieces. So, outside diameter of this part will finish at 1 5/16. We have some 1.5" cold rolled 1018 round stock that we're going to use. The part has a medium knurl, just like the first piece we made. It also has an 1/8 inch wide groove, which we're going to perform at the same depth as we did on the base, which is going to be, since it's a 1/16 radius that gives us an 1/8 inch width, we're going to go down or into the part a 1/16 per side, which means an 1/8 of an inch of diameter change from our 1 inch 14 thread call out right here. Now, when we turn this for the 1 inch 14 threads, instead of aiming for the perfect 1 inch, we're going to refer back to the standard, the thread standards from the machinery handbook, and for a 1 inch 14 thread, a 2-way fit, we have a max major diameter of 0.998 and a minimum major diameter of 0.988. So I'm going to aim for 995, and we'll call that good. If I'm a thousandths or two over or under, we're still well within the specification there. And I'm also going to go ahead and measure the pitch diameter when we thread this part. So that'll be a good video demonstration of that. A lot of times students forget to put this big 1/8 inch chamfer on. Right here it's 1/8 by 45. And like I mentioned in the previous video, or the video for the first part, the base, I'm going to make darn sure that my tap drill for this 5/8 18 is perfectly sharpened, because 18 threads per inch is, well, it's a fine thread, and we want to have as much thread as we should, so our drill needs to produce a very accurate hole size. Alright, let's go to the machine, cut some metal. Okay, so here we are. I got the part checked up, dialed in, running through. And what I'm going to do first is I'm going to touch off on the outside of the part. I'm going to dial in about 50 thousandths. I'm going to take a cut, I'm going to mic it, and then I'm going to input that value into the readout just like I did on the base. Okay, so I programmed the readout. Now I'm going to go down the part. It's 1.5 inches long. That's the finished part. So that'd be right there. But I also know that I'm going to part this off, so I'm going to go an extra 1/8 of an inch to 1 6/25, which is right there. Now that would be the bare minimum, and I'm going to go ahead and then just go another 1/16. So that's 1 11/16 down the part as far as the distance. And I could blue this surface, but I'm going to go ahead and just mark a line with the tool, and I'll be able to see it. And actually that round stock is 1 3/8. It's not 1.5 inches if I said that earlier. So the knurled section finishes, after it's knurled, at 1 5/16 inches. So that's 1.3125. I'm going to cut that to 1.3, because I know that my knurl is going to make that diameter grow by, 10 to 15 thousandths. So that'll be close enough for this. I'm at 1.375. I'm just going to go ahead and dial the cut and do it in one pass. Check it really quick with my digital caliper so the camera can read it easily. 1.3 is what we're looking for. And I'm at 295. It was about 296, 1 inch 296. It bumped out when I checked it, so that's fine. Now, when I review the print, I can see that my part's overall length is 1.5 inches, but there is a shoulder, and the shoulder width is going to be 5/16 of an inch. So I'm going to subtract that 5/16 from my 1.5 inches, and then I'll have 1 inch 3/16. So that's how far down the part I'm going to run the tool to make a mark, so I know where I should stop. Or actually, I know where to stop ahead of, and then hand feed the carriage over to that mark. Okay, so I'm at 1.1. I'll take a quick measurement before I go to my 0.995. Okay, so on the last pass I fed down, and then I fed out, and then that gave me a perfectly square shoulder. Now, I'm going to switch out my tool, and I'm going to put the radius tool in, and then I'll put the 45 tool in after that. Some ink on there, so now I'll see when the tool touches. So that's a nice visible indicator when I touch. Then I'm going to go in an 1/8 inch, that's a diameter measurement I'm talking about, a 1/16 aside, but an 1/8 on the diameter. All right, I got my 45 tool in, adjusted my RPM. Now I'm going to come in just like I did on the base until I make light contact with that edge. I'm going to zero the readout. And this is a big chamfer. It's an 1/8 inch down the part measurement. So that means I need to go an 1/8 inch into the part on each side. And I know that thing looks monstrous, but when I hold up a ruler, that is an 1/8 of an inch. There we go. I'll hit those with emery cloth and it'll make them a little bit smoother. I did add the cutting oil, and that's to help reduce the tearing.